Okay, here we have our whole LabVIEW project with three different main VIs. These are the files where the program is gonna run, and each main file has its respective sub VI. And we're gonna start by opening main number one. Here we can see four numeric controls. Each numeric control is to change the number of columns and rows of each of the different matrices that we have here. Uh, we created these matrices by nesting two for loops. We're gonna see that in a moment, but first we're gonna see how the program works. So okay, first I'm gonna change, let's say I want a square matrix, so I'm gonna change the number of columns and rows to 3, and the same for the second matrix. It's gonna generate a matrix of random numbers, as I'm gonna show you just in a minute, and it's gonna the program it's gonna run and do the its respective operations. Let's say a multiplication, an addition, and a subtraction of these two matrices. So I'm gonna run the program, and we can see that the program generated two matrices with different random numbers from 0 to 10, and we can see the results of the operations here. Let's say 2 times 1, it's 2, 6 times 3, it's 18, 7 times 7, it's 49, and so on. Also we can see that that with the subtraction, right? It's 1 minus 2, that will give us a minus 1. 3 minus 6, it will give you it will give us a minus 3, and 7 minus 7, 0, and the same with this with the addition, right? As you can see here. Now the program works this way. Let's open the sub VI, and we can see that we have here our two nested for loops, 1 and 2. The first one, let's say the one that is more out the outside, it controls the number of rows, and the one that is within that one controls the number of columns. Here I have my random number generator and a constant to say that I want those numbers generated from 0 to 10. First, what I do is convert to a double precision float number the let's say the number generated after the multiplication, right? This is just in order to manage the type of data that I'm manipulating, right? And I use this round to nearest in order to generate random numbers without the floating point, let's say without decimals, and in that way it's easier for the user to, let's say, use the VI, right? And here I only have each multiplication, sum, and subtraction of the data coming out here, right? Important to say is that let's say the output of the for loops are auto indexed. In a for loop it is auto indexed by default, and this is the way that we can manipulate each of the let's say in this way we can fill out our matrices, and that's just it. I wanted to do this instead of, let's say, wiring connecting all this mess that you see here. I wanted to do this with um, local variables, but I had a problem because it didn't run it at the same time that I wanted, and it didn't show the same values that I wanted. But well, this is just the way I solved it, and I think it's pretty clear, right? We can show another one. Let's say 2 columns, 2 rows in each one. Let's run the program, and here it is. And this is the sub VI that let's say encapsulates the whole process of the operations and things that I just showed you.